Hi everyone, welcome back to another discrete time. Whoa, not discrete time, it is continuous time problem. Today we're going to be solving for problem set 3.1, where our goal is to determine whether these systems h1 to h3 of t is causal and stable. So what we're going to do is to check our game plan. First, to check causality, what we are going to do is to check whether or not the system h of t is equal to 0 for t is less than 0. And then for stability, we're going to check the integral from negative infinity to infinity to positive infinity of the system h of t, the magnitude of the system h of t, to check whether or not it is less than infinity. So let's get straight into it. For the system h of 1 of t, what we're going to do, the best thing that I've seen was to be able to plot it out. Since we have a unit step, we can easily see that the system start at 2 because of this delay right here, and then this e to the negative 4 of t is just scaling the first height. So what we're going to do to find out for causality is to check whether or not the system is less than 0. And because of the unit step, we can see that the system is 0 for t less than 0. So it passes causality. For stability, we're looking at the integral. So we're going from negative infinity to 2 and into 2 to positive infinity. Since we know it's a unit step, we can quickly see that this turns out to be 0. So we're going to focus on 2 to positive infinity. And because of simple calculus, if you follow this right here, we can see that this system is equal to 1/2 e to the negative 8, which is less than infinity. So this system does pass the stability test. h of 2 of t is essentially the same thing, and we follow the same process, where we can also see that it is stable and it is causal. For the last system, h3 of t, it's a combination of unit step. Because of this delay right here of +2, we see that it starts at -2 and it cuts off at 4. So even though that this system is a unit step, we can simply say that the system h of t is not equal to 0 for t less than 0. So it does not pass the causality. And for h3 of t, we can conclude that this system is stable because it's a uniform system, which for stability, all we're checking is for the area under it, which we can quickly see that this system is stable because it is less than infinity, from negative infinity to positive infinity. Well, thank you and see you next time.